Okay, children, so in the previous lecture, we had done question number 10. One was homework. Two I had done for you, though I had not explained in the video. So now let us move to the next question. So next question is 3. Question number 3. Here the statement is 1 square plus 3 square plus 5 square plus dash 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 plus 2n minus 1 whole square is equal to n times in bracket 2n minus 1 in bracket 2n plus 1 upon 3. So the first step, let the given statement be Pn. Then Pn colon copy the question. That's all. Then we will take for n equal to 1, we get left hand side the term which involves n, bring it over here. Okay, then replace that n by 1. See how much you get. Here we are getting 1. Then right hand side, bring it over here, replace n by 1. See how much you are getting. 1. So here you observe that LHS is equal to RHS. So thus we have shown that the statement is true for n equal to 1. Okay, for natural number n equal to 1, the statement is true. Now what we'll do is we will assume that the statement is true for n equal to k. So we'll write let pk be true. Then you copy the same question. The only thing is wherever is n, you'll write k for it. Okay, then equation 1. Okay. Next what you will do is now from this pk statement you copy left hand side. Okay, put it in bracket. Again I have forgotten to put the bracket. Put in bracket. Okay, then you can see that this last term is what? 2k minus 1 whole square. So what you do, you will write over here this you have to write, but the thing is you have to replace this k by k plus 1. Okay, so you'll get 2 into k plus 1 minus 1 whole square. Okay, so you got this. Then is equal to on the right hand side for this from 1 square till 2k minus 1 whole square from the equation 1. Okay, we will get k into 2k minus 1 into 2k plus 1 upon 3 plus this. Okay, 2 into k plus 1 minus 1 whole square. Now you have to simplify this, and at the end, okay, you should be able to get, like here the last term was with n. Yes, with n over here 2n minus 1. Yes, the last term was 2n minus 1 whole square. So here you got n, this n is here, so here you got n 2n minus 1 into 2n plus 1 upon 3. But here we have the last term k plus 1. Yes, k plus 1. So on the right you should get k plus 1 in bracket 2 into k plus 1 minus 1 in bracket 2 into k plus 1 plus 1 upon 3. Okay, so you have to simplify this and you should get that. So here, okay, so I copied the same thing over here. Okay, here this is simplified, like here bracket is open, so 2k plus 2 minus 1, so you get 2k plus 1, okay, whole square. So here take the LCM. LCM is 3, so you get k times 2k minus 1, 2k plus 1 plus 3 times 2k plus 1 whole square. Okay, you can see in the numerator 2k plus 1, 2k plus 1 is common in both, so take it out. So you got 2k plus 1. Inside the bracket you are left with k times 2k minus 1 plus 3 times 2k plus 1 upon 3. Okay, open the bracket, you get 2a square, 2k square minus k plus 6k plus 3 upon 3 here. Then simplify, you get a quadratic expression. Okay, then 2 3s are 6. Think of two numbers whose sum is 5 and product is 6, and the numbers are plus 2 and plus 3. Okay, factorize it. Okay, then you get for this quadratic expression you get this k plus 1 into 2k plus 3. Okay, now you can see over here from the question, like here it had ended at n, so it was n, then 2n minus 1, 2n plus 1. Okay, so in our case it is k plus 1, so the first term should be k plus 1. Okay, it should be k plus 1. So here this k plus 1 I'm writing it first. Okay, then I should have 2k, I should have 2 into k plus 1 minus 1. Okay, so from this term I'm going to write it in this way. Okay, so here this can be written as 2k plus 2 minus 1. Still it is same. 2 can be taken out as common, so we get 2 into k plus 1 minus 1. And from this 2k plus 3 we can write 2k plus 2 plus 1. 2 will be common, so we will get 2 into k plus 1 plus 1. Okay, so thus here, like, it was n, it has the n term had k plus 1. Okay, so we have been able to get the right hand side in the same form, k plus 1, okay, into 2 times k plus 1 minus 1 into 2 into k plus 1 plus 1 upon 3. Okay, thus this is the statement for k plus 1. Okay, this is the statement for k plus 1. So thus we have been able to show that the statement is true for k plus 1 whenever you assume that the statement is true for k. Thus the Pn statement, okay, the statement Pn is true for all n belonging to natural number by the principle of mathematical induction. Done. Question number 4 is homework for you. Okay, question number 13, prove by the principle of mathematical induction that n into in bracket n plus 1 into in bracket n plus 2 is a multiple of 6. So this is a statement. Okay, this is the statement for us, n into n plus 1 into n plus 2, and we have to show that this is multiple of 6. That means we have to show that for every natural number, okay, this will be multiple of 6. That means this will be divisible by 6. Okay, so let us start. So for this type of question, you have to assume that this is we have to say that this is the statement Pn. Okay, so let Pn this, Pn colon this. That means here we are taking the given statement as Pn. Okay, so let Pn colon n into n plus 1 into n plus 2 is multiple of 6. Okay, so here we are taking this Pn with the statement, okay, this which is multiple of 6. Okay, so this is how you write. Okay, let Pn and this. Then what we'll do is we will check for n equal to 1 whether the statement is true or not. Okay, so we will put, for n we'll put 1. Okay, so for n equal to 1 the given expression becomes, so wherever you have n replaced by 1, so when you simplify you get 2 into 3 equal to 6. Okay, so and you know that 6 is multiple of 6 because 6 into 1, yes, 6 1 is 6, so 6 is a multiple of 6, so it is true. So the statement is true for n equal to 1. Okay, now what we'll do is we will assume that the statement is also true for k equal n equal to k. Okay, we assume that statement is true for n equal to k. That means pk is true. That means what we'll do is you will copy the same statement. Okay, the only thing is you'll replace n by k. So once I say pk is true, that means pk colon wherever you have n, write k is multiple of 6. Okay, same line. Okay, only n is replaced by k. Done. Then once you say that this k into k plus 1 k plus 2 is multiple of 6, like if I say 12 is a multiple of 6, that means what I can write, that means 12 can be written as 6 into 2. Yes, if I say 30 is multiple of 6, that means I can write 30 is equal to 5 into 6. Okay, 6 into 5. Yes, so same way if I am saying that this k into k plus 1 into k plus 2 is a multiple of 6, that means this k into k plus 1 into k plus 2 is equal to 6 into some natural number. Okay, some natural number, where m is some natural number. Like if I say 42 is multiple of 6, that means 6 into 7. Yes, I can write 42 is equal to 6 into 7. So same way if I'm saying this is multiple of 6, that means this is equal to 6 into m. Here m is some natural number. Yes, now give this equation 1. Okay, now what we have to do is we have to show that the statement will be true for k plus 1 also. So in this pk, in this pk what we have? K into k plus 1 in bracket k plus 2. Yes. So what you will do is you will copy the same statement. But the thing is, wherever you have k, you will write k plus 1. Wherever you have k, you will write k plus 1. So like here we have k. Okay, so I'll write k plus 1 over here. Okay, here I have got in bracket k plus 1, so I'll write in bracket, in place of k, I'll write k plus 1, then this 1 will come. Yes. Okay, I have got k plus 2, so here I will write k plus 1 plus 2. Done. So now what we'll do is we will simplify this, whatever we have on this left hand side. Okay, we will simplify this. Okay, and while simplifying, you should try to bring one term at least. Okay, you should try to bring one term on the right hand side which will be exactly equal to this, k plus 1 into k plus 2. So in that way what we can do is we can replace that term by 6m. Okay, that's why this equation is important for you. Okay, so here we assume that the statement is true for k. Done. That means it is multiple of 6. That means 6 times some natural number. Then what we'll do, then we have to prove for k plus 1. So wherever you have k, you will replace by k plus 1. So it's written. Now you simplify it. Okay, so k plus 1, the first term. Here in this second one, this will become k plus 2. So k plus 2. In this will become k plus 3. So k plus 3. Okay, now what we can do is, here you have this k into k plus 1, k plus 2. Okay, so from here, you have to try to take out this term k plus 1, k plus 2. Okay, you should try to get this term out of this. Okay, so how we can get that? So see over here it has k plus 1, k plus 2. Okay, here also I can see k plus 1, k plus 2. Okay, but I can't see into k. Okay, so what I can do is this k plus 1 and k plus 2. Okay, this whole can multiply to this k. Yes, k plus 1, k plus 2, this whole can multiply to this k. Yes, so I will get k times and this whole of this. Okay, k plus 1 into k plus 2. Okay, then this whole of this can multiply to this 3. So here plus sign is there, so that's why plus sign. Then 3 times this whole thing. Okay, done. Now you can see that you got this term over here. Yes, k times k plus 1 into k plus 2. But this is equal to what? By equation 1, this is equal to what? This is equal to 6m. Yes, so in place of this, okay, in place of this, you can write 6m. You can write 6m. Done. And here you have got 3 into k plus 1 into k plus 2. Okay, this step is repeated. Okay, so and here you get 3 into k plus 1, k plus 2. Okay, now you can see that this k plus 1 and k plus 2 are consecutive integers. Okay, like here if I take k to be 3, then it will be 3 plus 1 4, and here it will be 3 plus 2 will be 5. Like if this is 3, then this is 4. If this k plus 1 is equal to 5, then this will be equal to 6. Yes or no? So you should remember that product of two consecutive integers or natural numbers is always even. Okay, if you take product of two consecutive integers, okay, then it will be always even. So here you can see k plus 1 and k plus 2 are consecutive. Like if I say k plus 1 is 10, then k plus 2 will be 11. Yes, so that means k plus 1 into k plus 2 will give an even number. Okay, that means 2 times something. Yes or no? So k plus 1 into k plus 2 is even, implies k plus 1 into k plus 2 is nothing but 2 times something. Okay, that something will be q, that q will be natural number. So your then this expression, okay, whole of this will be equal to 6m, okay, 6m plus 3 into k plus 1 into k plus 2. But k plus 1 into k plus 2 is what? 2q, because you know that product of this will be even, that means 2 times something, so you got 2q. Okay, now 3 to the 6, so you got 6m plus 6q. Now 6 is common in both, so 6 comes out, so you get 6 into m plus q. Now you can see that you have been able to show that this, when you are taking the statement for k plus 1, okay, then you are getting something multiple of 6. You are getting something multiple of 6. Okay, so which is multiple of 6. Thus you have been able to show that the statement is true for k plus 1. Okay, it's multiple of 6, and this statement is true whenever you are assuming that the statement is true for k. Okay, so thus you have been able to show that the statement will be always true, okay, for any natural number. Now next I have left as homework for you, using the principle of mathematical induction, prove that n square plus n is even for all n belonging to natural number. Okay, so you have to do this by yourself, same way as previous question. Okay, next is prove that n into n plus 1 into n plus 5 is a multiple of 3. Okay, so here let Pn, okay, Pn, the statement Pn, okay, be this multiple of 3. Okay, done. Now we will check for n equal to 1. Okay, wherever you have n, put 1, so you get 12. Now 12 is multiple of 3. Yes, because 12 can be written 3 into 4, so it's multiple of 3. Done. So clearly 12 is multiple of 3. So statement is true for n equal to 1, that means P1 is true. Now we will assume that statement is true for n equal to k, that means Pk is true. Once I say Pk is true, then you'll copy the same thing. The only thing is n will be replaced by k. So Pk colon k into k plus 1 into k plus 5 is multiple of 3. Once you say that this is multiple of 3, that means this can be written 3 times something. So 3 times m, where m is some natural number. Okay, now next what you will do, you will copy the same thing, but what you will do is k will be replaced by k plus 1. So k plus 1, here you will get k plus 1 plus 1, k plus 1 plus 5. Done. Then in next step you simplify. So here k plus 1, so k plus 1, k plus 1 plus 1, so k plus 2, k plus 1 plus 5, that means k plus 6. Now from here, from this whatever you have over here, okay, from here you should try to bring one term to be this. Okay, you should simplify this and you should be able to get one term as this, k into k plus 1, k plus 5. Okay, so that you can use, in place of that you can use 3m. Okay, so you can see that here we have got k plus 1, k plus 5, but here I've got k plus 1, but I don't have k plus 5. But from this k plus 6 I can get k plus 5 plus 1. Yes, so now what I can do is, here this k plus 1 can multiply to this. Okay, so k plus 1 will multiply to this, so you get k plus 1 into k plus 5, then k plus 1 will multiply to 1, you'll get k plus 1. Done. Now I have got k plus 1, k plus 5, but k is not there. Okay, otherwise I could have used 3m. Okay, but here k is not there. But if this term k plus 1 into k plus 5 multiplies with k, okay, then I can get this. Yes, so we will multiply. Okay, so here k plus 1, k plus 5, okay, will multiply with this, whole of this. Okay, so I got k plus 1, k plus 5 into k plus 2. Okay, and this k plus 1 will multiply with this k plus 2. So here I got k plus 1 into k plus 2. In next step, this k plus 1, okay, into k plus 5 can multiply to k. Okay, then I can get k into k plus 1 into k plus 5, and then it will multiply with 2 also, so you get plus 2 times k plus 1, k plus 5 plus, and this k plus 1 plus into k plus 2. Done. Now for this k into k plus 1 into k plus 5, I can write 3m from 1. Okay, from this 1, okay, I can write this. Done. Now here I have 2 times k plus 1, k plus 5 plus k plus 1 into k plus 2. You can see k plus 1 is common in these two. So 3m plus km plus k plus 1 in bracket 2 times k plus 5 plus k plus 2. Inside the bracket, okay, you open these brackets. So you get 3m plus k plus 1 in bracket 3k plus 12. You can see 3 is common in these two terms. So you get 3m plus 3 times k plus 1, k plus 4. Yes. So again 3 is common, so 3 comes out. So you got 3 into something. That means whatever you will get, that number is going to be multiple of 3. So here I've written that clearly this is multiple of 3. So that means this statement for k plus 1 is multiple of 3. Okay. Thus you have been able to show that the statement is true for k plus 1 whenever you are assuming that a statement is true for k. Thus by the principle of mathematical induction, we have been able to show that the statement is true for every n, where n belongs to natural number. Okay. Next is prove that 3 to the power 2n minus 1 plus 3 to the power n plus 4 is divisible by 2 for all n belongs to natural number. So same way, let Pn be this statement. Okay, this is divisible by 2. Next, put n equal to 1. Done. You will get 10. Clearly, 10 is divisible by 2. Okay, so your statement is true for n equal to 1. Now we will assume that statement is true for k. Okay, so once I say it's true for k, so you copy the same thing, replace n by k. Okay, and once it is divisible by 2, that means what? This, okay, this whatever we have over here, this is 2 times something. Yes, because it is divisible by 2, that means 2 times something. Okay, where m is natural number. Now next step, you'll copy the same thing, but wherever you have got k, that will be replaced by k plus 1. Okay, so you got this. Now you have to simplify it. Okay, so after simplifying, you got this 3 to the power k, 3 to the power 2k minus 1 into 3 to the power 2 plus 3 to the power k into 3 to the power 1 plus 4. Now what you have to do is, you should try to, from here you should try to get this. Okay, you should try to get this. So here it is 3 to the power 2k minus 1. So I have got 3 to the power 2k minus 1. But I have also got 3 square also here in multiplication. Okay. So, and here I have got 3 to the power k. And here I have got 3 to the power k into 3. Yes. Here plus 4. So plus 4 is there. But the thing is, here we don't have anything in multiplication. Here we don't have anything in multiplication. But here I have got 9. Here I have got 3. Okay. So what I have to do is, I have to do some manipulation. Okay. So what I can do is, this 3 to the power 2k minus 1 simply, okay, into 9. It's already there. Then I need 3 to the power k. Okay. Here I have got 3 to the power k, but it is with 3 multiplication. So what I can do is, I can write plus 9 into 3 to the power k. Okay. Why I'm putting 9? Okay. I will write like here, I have got 3 to the power 2k minus 1 into 9. Yes. So these things also I'll write over here. Okay. With 9 into 9. Okay. With as multiple of 9. We'll write this 2 also as a multiple of 9. So that later on, this term will also have 9. This term will also have 9. This term will also have 9. So 9 can be taken out as common. So here 3 to the power 2k minus 1 into 9 plus 9 into 3 to the power k, okay, minus 6 into 3 to the power k. Okay, so here if you see, if you simplify this, okay, then again you will get this only. Yes, you will get this only. If you simplify this, you will get this only. And then I can write 9 into 4, okay, minus 9 into 4. I'm introducing this extra, okay, because I want 4, okay, and 9 should be taken out as common, and plus 4 from here. Now I can write 3 to the power 2k minus 1 into 9 plus 9 into 3 to the power k plus 9 into 4. This minus 6 to 6 into 3 to the power k here, and this minus 36 plus 4 will give minus 32. Now if you see from these three terms, 9 is common. Yes, 9 comes out. Then you can get 3 to the power 2k minus 1 plus 3 to the power k plus 4. And this, okay, this is nothing but 2m from equation 1. So you got this. And this side you get 6 can be written as 2 into 3, and 32 can be written 2 into 16. So 2 is common in these two. Yes, so 2 comes out as common. Okay, and here this can be written as 2m. Done. So now you can see that in these two terms 2 is common. Okay, 2 is common, so 2 comes out. So you saw that this whole number is multiple of 2. That means it is divisible by 2. Yes, so which is divisible by 2. So then this statement is for k plus 1 and it is divisible by 2. Hence we showed that statement is true for k plus 1 whenever you are assuming that statement is true for k. Thus, by the principle of mathematical induction, your statement is true for all n belongs to natural number. Done. So same way here, this question is there. Okay, prove that 3 to the power 2n minus 1 is divisible by 8. So solution is there. Go through the solution. Okay, and mainly here when you have to do some manipulations to get this comes with the practice. Okay, you have to understand what things should be subtracted, what should be put common. Okay, so once you practice, you will get this. Done. So go through the solution and you will understand it better. This question had come for last year. In fact, this year only in month of February or January, whenever this class 11 they had the examination, at that time this question had come. It was for 4 marks. Okay, so this type of questions come. I have done this, so you just go through the solution. Okay, so I'm not going to explain this. Okay, same way you have to do. Okay, and at the end I have left 3 questions as your homework. Okay, so this is all, and that's how this chapter gets over.